All right, howdy. So now we're on point 2. Oops, I haven't moved this one. We're on point 2, which is going to be about the potential energy connection, and that is 2. The potential energy for a charged particle is the potential at that point, the potential at its point, potential, spelling's even harder backwards, at its location, let's say that. So the potential is there, no matter what, there's always a potential there. Times, or scale, by its charge. And that's not too terribly difficult. That is the potential energy, the electrostatic potential energy. We can make that more complicated. Is going to be equal to the charge of the object, not the charge of the generating object, but the charge of the object being acted upon, times the potential at that point. Now, right now we've only calculated a potential difference, but that's not going to mean very much. Remember that when we're dealing with energies, what we generally care about is differences, right? So we have conservation of energy, which would be, Ki plus Ui is equal to Kf plus Uf. Right? So what's going to happen is that this potential here is going to, these potential energies are going to subtract in the final solution. Somewhere along they're going to subtract. So we're only going to have to worry about the potential difference. This is just like when we dealt with the height as the potential energy from something being tall, right? So if we had you up on this platform, right, depending on what we're doing, we can call this 0, right? We could say, if I want to figure out what's happening when you jump in the air or you throw something up while you're on the platform, I could call this 0, or I could call the ground down here 0 if I wanted to do something like jump off of it. Actually, it doesn't matter at all, because eventually you're going to just subtract those two potentials, right? Your potential at the ground level and your potential at the height, to figure out what's going to happen with the speed or whatever other thing that you're trying to figure out in the problem. But usually we'll be looking for the speed in a problem like that, right? So the potential difference that we talked about last time is going to be related to this, because you're going to subtract the total electrostatic energy from both sides. And if you have a reference that you're going to calculate from, that reference is going to be subtracted. If you have a reference, you have to use the same reference for both of these. And this is going to be important for the next segment, which is going to discuss what happens when you have the potential generated from a charged particle. Right? So I should mention that there are two special cases that we'll look at. We'll look at these two special cases that are very important. The first special case is going to be the case that I'm just talking about here, something like this, and that's going to be the potential inside of a circuit. So the next unit, the next module, is going to be all about circuits, and we're going to use all of this stuff we've been talking about with fields and potentials in the circuit to try to describe what's going to happen to electrons moving around in a wire, which you can think of as sort of a tube that contains electrons. It's a little bit different, but you can think of it that way and it'll help. You can think of the wires as pipes. In that case, we're going to ground the circuit somewhere, and that ground is going to tell us where V is equal to 0. All right. The other case is the one we'll look at in this module, the module that we're finishing up, or at least a little more in this module. And in that case, what you have is you have a lot of point particles. Each one of those point particles has a potential coming off of it. And in that case, what you need to do is you need to take the potential to be 0 at infinity. Okay? And we'll talk a little bit more about that next time, why that is. But you'll need the potential to be 0 at infinity instead. And there could be other situations that you have to worry about. In those situations, choose whatever is simplest. Right? That's the point of all of this stuff. Where you have a situation where you can get to choose where the 0 of the potential is, choose what the simplest one is. Right? Eliminate as many variables as you can by choosing that potential to be 0. All right? Okay, so that is enough for this. I'll do an example in just a moment, and that example will be basically a parallel plate capacitor, and we'll figure out the speed of an electron that's been accelerated through one of those things, like in an electron gun. An electron gun will do something like that. And then we'll go back and we'll do part 3. Part 3 will discuss, like I said, the potential from a charged particle, and we'll deal with a potential energy problem in that situation as well. All right. After that, we'll be ready to go on to do circuits, and we'll do some simple circuit problems for about a week. All right.